Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about the second review sheet for Chapter 2 Solving Equations. So the second review sheet for Chapter 2 Solving Equations. And we're going to talk about the first four problems on that sheet, mainly the application problems. So let's start with number one. It says at Bill Grimm Chevrolet in Peoria, customers can get a car wash and an oil change for $50.25. Bill Grimm is now selling a discount card for $168 that allows customers to get a car wash and an oil change for $26.25. Part A says write an equation for how much someone without a discount card would pay to Bill Grimm Chevrolet based on the number of times they get a car wash and oil change. So for part A, this is number 1A, we're talking about someone who does not own a card, a discount card. So for an oil change and a car wash, they're going to have to pay $50.25 each time they go get a oil change and a car wash. So we can represent T as the number of times that they go get that done, and let's say this is going to be equal to some variable. I think in the worksheet I used the variable P. So P here is how much someone without the discount card is going to pay totally to Bill Grimm after a certain number of times of going to see him for an oil change and a car wash. Okay, so T again represents the number of times that they're going to get this car wash and oil change. Then in part B, so 1B, it says write an equation for how much someone with a discount card would pay to Bill Grimm Chevrolet based on the number of times that they get a car wash and oil change. So the person with the discount card, they don't pay as much for the oil change and the car wash. However, they have an early upfront cost that's a little bit more. So for their expression, we said D is the total cost that someone with a discount card would pay, and we can say $168, so we have to calculate how much they spent on the card to get the card, because that's money that they had to pay out of their pocket. Plus, it told us they only pay $26.25 every time they go get a car wash and oil change. So that's T then represents the number of times that they go get a car wash and oil change. Okay, so here's the cost of the discount card. Here's the new cost of the car wash and oil change. Okay. So now in part C it says, how many times would it take the card holder and the non-card holder to get a car wash and oil change and have spent the same amount of money at Bill Grimm Chevrolet? So 1C here, number 1C, we've got two equations. P equals 50.25 T and D equals 168 plus 26.25 T. Now again, this is how much someone without the card will pay totally, and this is how much someone with the card will pay totally. Now, this person here, it may seem like they're getting a good deal, but really the good deal doesn't start to happen until they use the card often, because they have to pay that initial upfront cost of $168. But if someone's only going to go and get an oil change or car wash only a couple times a year, then it probably is not going to be worth it to purchase the card. And so what we're really looking for is, when does this cost P equal this cost D? Okay, so really what we can do here is we can say that this is both of these equations are going to be equal to the same number, so the cost. And since they're going to be equal to the same number, we can set them equal to each other. Equals 168.2625t. Okay? So again, since we know that we want the costs that a non-card holder spends and the card holder spends to be the same in the end, we want those two costs to be the same, then we can really say that the same variable for part C and then set the two equations equal to each other since they're equal to the same. And then you would solve this for t. So minus 26.25t from both sides, you're going to get 24t equals 168. Then divide by 24 on both sides, and then t is going to equal 7. So t here represents 7 times that it's going to take for this person and this person to go and spend their money getting oil change and a car wash at Bill Grimm. However, their costs then at 7 times would be the same. So let's look at this in maybe a little different light. So if I made a chart for a non-card holder, and let's say this is the number of visits, and let's say this is total spent. Okay? After one visit of a non-card holder going to get an oil change and car wash, they would have spent $50.25. After 2 times, they're going to spend $100.50. After 3 times, they're going to spend $150.75. And so on and so forth. Okay, but the card holder let's say this is number of visits again, and this is total spent. If you're a card holder and you go the first time, not only have you spent $168 to get the card, but you've also spent $20.25 on getting the oil change and car wash. I'm sorry, $26.25. So when you add those two together, your total cost after one visit has been $194.25. And again, this number comes from the fact that we've already purchased the discount card of $168, and then we had to pay the $26.25 for the oil change and the car wash. So now, each time that they go to the car wash, or to get that oil change and car wash, they only increase by $26.25. So the second visit, they've totally spent this much. The third visit, they would have spent $246.75, and so on and so forth. Okay, so eventually this person is going to catch up to this person because they're increasing at a greater rate here than this person is. Okay, and then what we were looking to find in part C was when does this number become the same for both of these, and then how many visits does that take as we extend the chart. If we extend the chart out this way, how many visits will it take for this person, the total cost, and this person, their total cost, to be the same? That's really what we were looking for. And then if we see a graph here, if we look at a graph, and this is total spent, and this is number of visits. So the card holder, someone that is a card holder, is going to initially start off with their total spent at $168 versus someone who's not a card holder is going to start off with 0. Now every time that the card holder, someone with a discount card, goes to the car wash and gets an oil change, they only have to pay $26.25. So they're going to increase at a smaller rate. So we could say a line like this. But someone without the discount card is going to pay a greater amount for that car wash and oil change. So they are going to increase at a greater rate. So for the person who has the discount card, it's really not worth it at the beginning to purchase that card because you've spent more than someone without the card. But over time, as you can see, this person's going to pay less than this person as you use the card more and more. What we were looking to find in Part C was, where do these two intersect? Where is it the same? Where is the total spent going to be the same? So we said that that number here on number of visits was 7 visits, and the actual amount of money would be $50.25 times 7. So the actual amount of money would be $351.75 here. So how much they, the number of visits, 7, each of them would have spent $351.75 at that point. Then the non-card holder is going to increase at a much greater rate versus the card holder. So let's talk about number 2 on the second video.